Okay, welcome to another bite-sized video from Simi. We're talking about non-vanilla flavored trig equations, and the assumption here is that you've watched the previous video on vanilla flavored trig equations, because in this video we're not necessarily going to solve all the equations, we're just going to give you strategies for doing so. Right, let's dive straight in. So very often we end up with sine and cos in the same equation. There are essentially two types of these. We need to know how to deal with both. The first type is where the two ratios are both acting on the same angle. And so what we can do is we can just divide both sides of the equation by the cos of that angle. And as we know, sine over cos is tan. So we now have basically a vanilla flavored trig equation, which I'm not going to solve, right? But we do know that we will get half as many solutions as usual because of the theta over 2. Right, so only 1 every 360 degrees. And we also, remember with tan, remember that we can go plus 180k to either of our solutions. Right, if we do not have the same angle, in other words, we've got sine and cos in the same equation but not acting on the same angle, then the strategy is to change one of the ratios to the other using our 90 minus reduction. So we change to its co-ratio. Just before we do that, just remember that if we end up with sine of alpha equals sine of beta, then there are two possibilities. Either alpha is beta or alpha is the supplement of beta. And that makes sense looking at the cast diagram, because remember that sine of 180 minus beta is exactly the same as sine of beta. Right, so when we kind of drop the signs, if we've got sine of something equals sine of something else, remember there are two cases. Likewise, if we've got cos of alpha equals cos of beta, there are two cases. Either alpha is beta or alpha is 360 minus beta. Because remember that cos of 360 minus beta is the same as cos of beta. Right, let's dive into an example. So we're going to find the general solution to this equation. Notice that we cannot divide by cos of 3 theta plus 10 because we won't get tan. All right, so what we're going to do in this case, and you've got a choice, you could either change cos to sine or sine to cos. We're going to change the sine 2 theta plus 5 to cos of 90 minus that. That simplifies to that. And now we've got cos of something equals cos of something else. So we're going to use the peach sort of colored box up there. So either those two angles are equal, plus 360k to one of them. All right, and we solve that. Or one of them is 360 minus the other one. All right, and we solve that. And there's our full general solution with kind of two parts, both the underlined parts. Right, what about this one? Okay, well, I'm hoping we won't divide through by sine theta, because doing so we would lose the solution. We must rather factor it. It's a quadratic. Okay, and so we get that. Now just be careful, because we said every trig equation typically has two solutions per 360 degrees. But the sort of points on the axes, as well as the extreme points of the function, the sort of maximum and minimum values, they occur slightly differently. Let's just look at a sine graph. We can see that sine is 0 every 180 degrees from 0 onwards. And sine is a minus 1 only once between 0 and 360 degrees, and that's at 270. And then that will repeat every 360 degrees from then on. So there's our general solution there. Okay, what about this one? Also a quadratic. All right, it's a quadratic in cos, and it factors out quite quickly, and we end up with two vanilla equations. Lastly, what about this one? This one looks like a quadratic equation, but it would be nice if that cos squared was rather a sine squared. Well, remember we have an identity that sine squared plus cos squared is 1, so we can change that cos squared out to a 1 minus sine squared. And now we have a trinomial in sine, which we can solve. We end up with two vanilla flavored equations. Well, ish, right? Because remember, sine theta equals 1 is that sort of unusual one which only occurs every 360 degrees from 90. Hope you found this useful, and hope you have a great day.